Hey, welcome back. There's something I like to think of as the line of total incomprehension. Take the n+1 problem. If n's odd, you add 1. If it's even, you cut it in half. Then repeat. This is easy to analyze. Every time you add 1, that results in an even number, which you immediately cut in half. So after 2 steps, you wind up lower than where you started. So anywhere you start, you're eventually going to wind up at the number 1. Now take the 2n+1 problem. If n is odd, you multiply it by 2 and add 1. Well, this takes you to a bigger odd number and then a bigger odd number off to infinity. So that's also easy to analyze. Now take the 3n+1 problem. Complete chaos, as we've seen. You're innocently walking along and suddenly you cross the line of total incomprehension. This happens a lot in math. For example, is there a rectangle where the length and width are both integers and the diagonal is also an integer? Sure, there's zillions of those, like 3, 4, 5, 5, 12, 13, so on. How about a three-dimensional brick where the length, width, and height are all integers and all the diagonals on the faces are integers too? For sure there's that brick exists. The smallest one has dimensions 44, 117, and 240, with the diagonals 125, 244, and 267. It was discovered in 1719. A computer could find it in a microsecond. Now, here's another question. Is there a brick where the internal dialogue is also an integer? Oops, we just crossed the line of total incomprehension. Because we've reached the unsolved perfect cuboid problem. Nobody knows if a perfect cuboid exists. If it does exist, it'll have to be a big-ass cuboid.